Hello guys, welcome back to the school. With you, Ms. Ghada Muhammad al-Barbari. I am your math teacher and the head of the math department. This year, I'll teach you the calculus or the advanced math curriculum, okay? Before I begin this lesson, we need to define some vocabulary. Like, what is the meaning of limit? Because our lesson today is talking about the limit of the function. We can find the limit of the function by different way, okay? But before I talk about how we find the limit of the function, I have to know what is the meaning of the limit of the function. Okay, what is the meaning of the limit? What is the meaning of what? The limit of what? The function. We mean by the limit the behavior of the function. The behavior of the function. The fx goes where? Goes where? Or approaches to which value? Approaches to which value? Okay, when x approaches to a given value. Okay, here, as you see in this problem, for example, I'll explain some vocabulary on this problem. Okay, here, how to read this one? We refer to the word limit by using L-I-M. We mean by this limit. Okay, how to read it? For example, limit x squared minus 3x plus 2 over x minus 2. The limit of the rational function, the limit of this called rational function fx. The limit of this rational function, x squared minus 3x plus 2 over x minus 2, when x approaches 2. Miss, I don't know what is the meaning of this one. X approaches to 2. I refer to the word approaches. Approaches, okay, to approach. What is the meaning of approach? Very close to it, very near to it, very near to it. Close, there is no distance between these two numbers, okay? Very small distance between them, or the difference very, very small, okay? How we read this one, please focus with me how we read the problem, how to understand the new concept. X approaches to, it means x very close to it, okay? But it doesn't mean x equal 2. It doesn't mean x equal 2. Understand? Okay. So, how to read this one? Find the limit. What is the meaning of limit? What is the meaning of limit? Behavior. What is the value of the function? The function goes to which value? That is the meaning of limit. The function goes to which value? Okay? Or the behavior. That is the meaning of behavior. Okay? For the rational function x squared minus 3x plus 2 over x minus 2, when you have to read this line later. When x approaches 2, I have to write what? Limit, look here, fx, when, look here, when x approaches to what? 3 or any value, a or any value a of number. Understand or no? Here we name it limit. Don't say lem, no, limit. I read this part first, limit, then fx, then when x. We read when x approaches to 3. I told you how to read. What is the meaning of approach? Very close. Understand? What is the meaning of limit? It means the behavior. What is the value of it? The function goes to which value of y when x approaches to a given value, as in our problem. I think it's clear up to now. That is the definition of some vocabulary that I will use in this one. Look here. Our lesson today is talking about how to find the limit numerically. numerically. Okay, how to find the limit numerically? By making table, by making what? Table, or completing table, as you see. In this case, we follow these procedure, which are, I use two sets of number. I use two sets of number. Here, as you see, sets at the right of 2, which I'm finding the limit when of the function when x approaches to 2. Okay, all of these values, or all of the sets of these values of x, which at the right of 2 greater than it, and very close to it. In this case, we say x approaches to what? 2, but since it is greater than it, we write from right. Okay, all of the values which are near to 2, okay, we refer to it by what? And greater than it, we refer to by 2 and write a plus above it. The other sets of number here at the left of 2, it means less than. Okay, we say x approaches. This arrow means approaches 2, but less than it means from left. Greater than, it means what? Greater, it means what? Greater than, it means right, from right. Okay, smaller than, it means left. Smaller than, it means what? Left. Understand? In this case, to find the limit of the function numerically, we have to use two sets of number, okay? X greater than 2, but very small to it. That is why we say x approaches to 2, approaches, yeah, near or close, okay? From right, we refer to from right by writing positive or plus above the value of x. Okay? That is my procedure. I have to use two sets. That is the first step. Use two sets of number. What is the second step? Substitute. Substitute by each value of x in the function. In this function, okay? Use the calculator. I know all of you can use the calculator. If you replace, you will find the result by using calculator 0.75. Okay? If you replace in the function, it will be 0.9. It's very important. Just substitute. It's so easy. The other one, it will be 0.99. The fourth value, it's enough 3 values, but here I give you 4 values to make sure. Okay, the first one here, it will be what? 0.999. If you replace by 2 in this function, you will find the function undefined, and your calculator will give you what? Math error. Math error. Math error, it means the function undefined at this value. And it is very important to know this one. When we find the limit at the value of x, okay, it doesn't mean the function defined at it, because I find the behavior of the function when x approaches to this value of x, but not equal to it. So that is why I don't care when I find the limit, the function defined or undefined at this value. By substitute by the values of x in the function, in this function, okay, which I find its limit, okay, it will give you what? 1.001. 1 point, and you can make sure by using your calculator. 1.1, then 1.25. I hope you understand and know how to substitute. I think it's so trivial. That is the second step. The first one, I have to write the value, but in the exam, inshallah, I will give you the table. But if I don't, you have to just add. Add 100, 1,000, 1/10, like this one. Very small number to find the value which approach to 2 and greater than it. Here, just subtract 1,000 from 2, 100, 1/10 to find the value which is very close to it but less than. Here, the third step, I have to find what the values here of fx when x approaches to 2 from, look here again, as you see, the value of fx approaches to which value when x approaches to 2 from left. When we replace by the value of the x which is less than 2, but very near to it, very close to it, fx approaches to which value? Goes to which value? Approximately, approximate. All of these value approximately 1. Approximately what? 1. If we, here as you see, all of the whole number the same, I can decide this one. But the tens here are different, 7, 9, 9, 9, no. In this case, round to the nearest whole number. You can find this one mentally. Approximately represent 1. But as I round here to nearest tens, I round the others sets to what? Tens. Here, as x approaches to 2, from what? Right? It means, what is the meaning of right? More than. Okay? Fx approaches to what? As you see here, means it's so clear also what? 1. Set is the value of the function. Approaches to the same value. Okay? As x approaches from left or approaches from right, in this case, the limit exists. The limit what? Exists. And it will be add the value of this approximation. In this case, we will write, look here, what is the limit? It means what is the value of fx approaches to it, approximately approaches to it, when, look here, when x approaches to 2, it will be 1. As these two what? Value. As these two value. Clear or not clear? I think it's so easy. We defined in this example, what is the meaning of limit? Behavior. Function fx goes to which value? What is its value? Approaches approximately each value. When x approaches to a given value here, as you see, to x equal 2. We have to make table in which we have two sets of number. The first set, all of the value, which is very close to the value that we find the limit at it, okay, and the values less than of it. Replace in this function, just replace all of it, just to complete only the table. If you don't understand, but you have to know what is the meaning of approach. What is the meaning of approaches from right? What is the meaning of approaches from left? Understand? What is the meaning of limit? Behavior. Behavior. What is the value? Goes to which value? If the value of fx, that is what? Fx approaches to the same value, as you see here, as x approaches from left or approaches from right, in this case, limit exists and it will be the same as these two values. Okay, if they are different, limit does not exist. I think it's so easy. Okay, let's solve another one. Let's solve another one. Clear this one? Sorry. Okay, now focus with me. Here, who will help me in this one? Okay, now complete, read. Usually, please, you should usually read the head of the question to understand what is the request here. Complete the table and use the result to estimate the limit. It means, what is the meaning of limit here? The value fx goes to it, that is its behavior. It goes where? Where are you going? It goes to which value of y when x approaches to what? Look here, approaches to 4. As you see in this table, I have two sets of number. The first set, The second what? Set. The first set here, all of the values very close to 4, but more than it, but it means x approaches to 4 from what? Right. How to write any expression for this one? What is the meaning of right? Right plus above it. Okay? And here, all of the values of x less than 4 means x approaches to what? 4, but from left. From what? Left. We denote the values which less than 4, okay, by writing a minus above it. Okay, that is the first step. I have to identify what is the two sets which I should have. Then replace, that is the second step. It's so easy. Replace in the function. Replace in the function. Okay, what is this value by using calculator? 0.2040. Miss, some of you will tell me, Miss, I have an infinite number of decimal places. Infinite number. What I have to do? Just take 4 decimal places from each result. Only 4 decimal, it's enough. Okay, it's enough. I will take 4. Here in this case, 0.2004. The other is 1 by using calculator. That is the first value, second value. Third value, 0.20004. Okay? Now I will find the values of fx here, and the fx what here, and you can write, but to make you see the answers, okay, easily, I write big number, but you can write in the squares, empty squares. Okay, it will be 0.19996. I take here 5 or 4, no problem. Okay, here 1, I will take what the other one, 0.1996. The others one, 0, okay, sorry, 0.1996. Sorry, 6. Now, what is the third step? That is the second one. Third step, I have to know fx approaches to which value? Look with me here. Approaches to it approximately. Approximately equal what? Maybe whole number, maybe 1 decimal place, maybe 2 decimal place, as you decide. Here it's so clear, whole number is the same. Like the same. Miss, here in this case it's so clear, approximately what? 0.2. Mentally, Miss, all of them approximately 0.2. That's right. In this case, as I round in the left result, okay, to nearest tenth, around here to nearest what? Tenths. To nearest what? Tenths. It will be 0.2. 0.2. Someone else tell me, Miss, I round to the decimal places, to decimal 0.20. 0.20 is the same. Here, if you round this one, 0.20. If you round to nearest tens, it will be as we round to nearest hundreds. No problem. If one round, but both sides must be round to the same decimal place. Okay, here, since the round or the value of fx, okay, when fx approaches to 0.2 when x approaches to 4 from left, and fx approaches to 0.2 when x approaches to 4 from right. They are equal. In this case, the limit exists. The limit what? Exists. And it will be like them. Like what? Them. So in this case, I write what here next to the question of our problem. Approximately what? 0.2. That's all. Means it's so easy. I understood what is the meaning of limit, the behavior or the function. What is the value of the fx approaches to it when x approaches to a given value here. That is the meaning of this one. Fx, this is function, that is my function, fx, approaches to which value of y as x approaches to 4. Okay? If fx approaches to the same value as x approaches from right or from left to a given value, so the limit exists, as you see here. Okay? And the limit will be the same. Just to complete the table, round the values of fx, okay, when x is less than 4 here, and round the value of fx when x, I'm so sorry, when x more than 4, if they are the same, after rounding, will be our limit. I hope you understand. Try to watch the video many times to understand. Please focus on the vocabulary. How to read the head of the question. How to read the head of the question. For example, this one, how to read this problem. Limit. I don't say lim. Limit. Rational function. X minus 2 over x squared minus 4. When, the last one, here 1, second, third. When what? X approaches to. Understand? So I have to find the value of the function, where the function approaches to which value of y as x approaches from right or from left. If they are the same, in this case, we have limit, and it will be like them. But if they are different, limit does not exist. You can round this one mentally. Sometimes you can round to 1 decimal place, 2 decimal place, 3, but round to the same decimal places both sides. Okay? Thank you for joining our session. Or watching our session. Have a good luck. Please try to solve your homework. Homework, it will be question number 2 and question number 3. Just complete the table, round the value of y in both sides, the 3 values at left and 3 values at right. Round, okay, if they're the same, the limit exists, and it will be like them. Thank you, and have a nice day. Bye-bye.